Calculus examples, logarithms. This is video 26. In example 4, y equals log base 10 of x plus sine of x. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Finding the derivative. Let y equal log base b of f of x. Call this equation equation 1. The objective is to find log base b in terms of line and then modify the verbal form of the chain rule to find the derivative of y. Finding log base b in terms of line. Cancellation equation C2 is b to the log base b of x equals x. Now replace x with f of x. So b to the log base b of x becomes b to the log base b of f of x equals x becomes f of x. Then take line of both sides. Line of bring down equals line of bring down. Apply law of logarithms L3, which states that line of x to the y equals y times line of x. Since y is log base b of f of x, replace y with log base b of f of x. Since line of x is line of b, replace times line of x with times line of b equals bring down. Divide both sides by line of b. Bring down divided by line of b equals bring down divided by line of b. Now cancel line of b in the numerator with line of b in the denominator. Thus, log base b can be replaced by line divided by line of b. Call this statement Statement 1. Equation 1 is now replace log base b with line divided by line of b. Call this equation equation 2. Thus, equation 1 has become equation 2, which is easy to differentiate. To review the above working, you should pause this video now. Modifying the verbal form of the chain rule. Equation 2 in Scene 2 is. Call this equation equation 3. From reminder 2 in Scene 6, the verbal form of the chain rule is shown below. It finds the derivative of line of f of x. But line of f of x in equation 3 is divided by the constant line of b. So append divided by line of b to the verbal form of the chain rule as shown below. Call this equation equation 4. Equation 4 is the modified verbal form of the chain rule, which finds the derivative of the function in equation 3. The procedure in the yellow box below combines statement 1 in Scene 2 and the modified verbal form of the chain rule in equation 4 to find the derivative of the function y equals log base b of f of x. To find the derivative of y equals log base b of f of x, identify base b, then replace log base b with line divided by line of b, which gives y equals line of f of x divided by line of b, where f of x is the argument of line. Then equation 4 states that from the last line in the yellow box, y dash of x equals the derivative of the argument of line is the derivative of f of x, which is f dash of x, divided by the argument of line, which is f of x. So substitute f of x divided by line of b. So substitute divided by line of b. Therefore, y dash of x equals f dash of x divided by drop f of x into the denominator times bring down line of b. Call this equation 5. To review the above working, you should pause this video now. Example 4. Find the derivative of y equals log base 10 of x plus sine of x. Solution. Since y equals log base 10 of x plus sine of x, the base is 10 equals, from statement 1 in scene 2, with b equal to 10, log base 10 can be replaced by line divided by line of 10, then bring down x plus sine of x, which is the argument of line. So y dash of x equals the derivative of the argument of line is the derivative of x plus sine of x, which is 1 plus cos of x divided by the argument of line, which is x plus sine of x. So substitute x plus sine of x divided by line of 10. So substitute divided by line of 10. The derivative has been found using the modified verbal form of the chain rule. Equals bring down 1 plus cos of x divided by drop x plus sine of x into the denominator times bring down line of 10. Do not forget the brackets. You should review common errors in scene 8. Final statement. The derivative of the function y equals is y dash of x equals. To review the above working, you should pause this video now. When solving questions from your textbook similar to the example in this video, you will find it helpful to display scene 3 so you can use it as a template to find the derivative. If you prefer to use a formula to find a derivative, you should review equation 5 in scene 3. You should then find this topic simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook. Reminders displayed without commentary. To review the above reminders, you should pause this video now. Finding the derivative of y equals line of x plus sine of x divided by line of 10. Call this equation equation 6. The derivative of y is found using the modified verbal form of the chain rule in equation 6. It was derived in scene 3. When y equals line of x plus sine of x divided by line of 10, where x plus sine of x is the argument of line, then y dash of x equals the derivative of the argument of line is the derivative of x plus sine of x, which is 1 plus cos of x divided by the argument of line is x plus sine of x, so substitute x plus sine of x divided by line of b, which is divided by line of 10. So substitute divided by line of 10. To review the above working, you should pause this video now. Common errors displayed without commentary. To review the common errors, you should pause this video now.